Hello everyone, how's it going today? I hope you're having a great Friday so far. I wish I could be here with you, but I will see you back on Monday. We have been talking a little bit about quadratics and some different operations that we can use with quadratics. So we've been learning about the transformations. We've been learning that the quadratic function will make a U shape, whether it's right side up, upside down, stretched, compressed, reflected. We can do a bunch of different things with that. Today what we're going to be talking about is solving quadratic equations. So instead of always doing things with graphs, graphs take a while, and there's things that we can find out about a function simply by using the equation that's already there for us. So one thing I'd like to talk about first is a couple vocab terms. So this first one here is a zero, which is also sometimes called a root. These are the points or the x values where a graph crosses the x-axis. The reason why they're called zeros is because at this point you'd have a y value equal to 0. We also have different types of quadratics or polynomials in general, but right now we're just talking about quadratics. The first one of those is a trinomial. So we'll talk about it in terms of quadratics, which is going to be a quadratic with 3 terms, and then a binomial is going to be a quadratic with 2 terms. If you want an easy way to remember this, think of a bicycle or a tricycle. Bicycle has 2 wheels, tricycle has 3. A trinomial has 3 terms. A binomial has 2 terms. We also need to talk a little bit about something called the zero product property. So we all know this already, simply by what we've been taught our entire lives. But now we're going to write it down in a little more formal way. So the zero product property simply says if you multiply 2 things together, so we'll call those 2 things A and B. If you multiply them together and they equal 0, then either A equals 0 or B equals 0. So there's no way to multiply 2 things together and get 0 out unless one of those things is 0. That's pretty much what this says here. So now let's actually work on some example problems. A lot of you probably remember doing factoring stuff in Algebra 1, and you probably have seen some of this already in Algebra 1. So this might be a type of review. However, I want to just go through this a little bit, and I might teach you a different way than somebody else did. So we will move right along here. All right, so pretty much what we want to do is we want to find the zeros or the roots of this function over here. So the way you can do that, we don't have a 0 in there yet, so let's go ahead and start by just setting this equal to 0. Now I'm going to teach you something called the power x. The power x is you're just going to make an x on your paper. What you're then going to do is you're going to take the coefficient out front here, which here is just going to be a little 1. And then the last number, you're going to multiply them together. So 1 times -3 is -3. You're going to put the middle number on the bottom. At this point, what you want to do is you want to see what 2 numbers multiply to give you -3, but add together to give you positive 2. This is a pretty easy one because they're small numbers. The answers are going to be 3 and negative 1. So if you multiply 3 times negative 1, you get negative 3. If you add these together, you get positive 2. And then what you can do is you can simply write these as x plus 3 and x minus 1. Again, this is the same function as we had up here that we set equal to 0. So this is still going to be equal to 0. Now the zero product property comes in handy here because we know that we have two things that are multiplied together. And if those two things multiplied together equals 0, then either x plus 3 equals 0 or x minus 1 equals 0. So down here I'm going to show that. And then these are very elementary algebra problems to solve. Either subtract 3 and add 1, and then you get x equals negative 3 or x equals 1. So those are our two solutions. And graphically, if we were to want to know what this looked like, what would happen is we'd have a U shape, and it would cross at x equals negative 3 and x equals 1. We want to know some of the benefits of knowing exactly, why are we using quadratics? We have many applications in the real world that follow a quadratic or parabolic arc. Pretty much anything that's flying through the air is going to have that arc if there's no propeller on it or something powering it. So if you think of throwing a baseball, hitting a baseball, football, basketball, when you throw it in the air, you can kind of see that it goes up in the air for a little while. It goes up in the air for a little while, and then it'll come back down, and it'll make that type of shape. So that would be like an upside down version. These ones are going to be right side up, but you do the same thing for an upside down version. A lot of our real world applications will follow this pattern. So this is a separate thing, but just so you can kind of see there an application. All right, the next one, number 2. I'm going to have x squared minus 5x minus 6. Again, I want to find the zeros or the roots. And I'm going to solve this by first setting it equals 0. Set up my x. Negative 6 times 1 on the top. Negative 5 on the bottom. What multiplies to give you negative 6? And adds to give you negative 5. It's going to be a negative 6 and a positive 1. So x minus 6, x plus 1. Again, we still have to make sure this is equal to 0. So we don't actually change the problem. So then over here we can say, well, x minus 6 equals 0. Or x plus 1 equals 0. Add 6, x equals 6. Or subtract 1, x equals minus 1. Again, graphically, we could kind of envision that this would have a crossing point of where it would cross the x-axis at 6 and then at negative 1. All right.